has an odd multiplicity because it appears once, and x equals -1 has a even multiplicity because it appears twice. Okay. Do you know any function that has a double solution at the point? X squared. What does x squared have at 0? A what? Term. So every even multiplicity is a term. Every odd multiplicity, now let's think of the linear function. How many times does a linear function cross the x-axis? Right. So every odd multiplicity will be a cross. Cross of the x-axis. Turn on the x-axis. Cross on, I meant to write. Cross, no, I meant to write of the x-axis. And turn on the x-axis. Right? So if a solution appears once, 3 times, 5 times, at that point the function will cross the x-axis. If a solution appears twice, 4 times, 6 times, what will the function do there for sure? Turn on the x-axis. Okay. However, this is one last thing. I hope I didn't lose you. I don't want to lose you. There are different ways of crossing and different ways of turning. So for crossing, and then for turning. Here's how a function can cross. What is the multiplicity here? 1. But look at this one now. What is the multiplicity here? And it cannot be 1. So this is my, but can it be 2 if we are in odd? It crosses. So the multiplicity here is 1. What is the multiplicity here?
More than 3.
Exactly. What about here? Very good. That's the idea. Because it's flatter than this. It takes even longer. There is only one cross, but it takes even longer. Okay, here's a turn. And here's another type of turn. What is the multiplicity here? What is the multiplicity here? That's it. And the flatter it gets. Okay. We're done. But I have to go back to my chart. So here you said to me, -1, comma 0. And we know now that this is a turn. And I make myself a note. It's a turn. And then you said 3, comma 0. But since the multiplicity is 1, I'm going to say it's a regular cross. So I make myself a note. Now I would like you to bear with me for a second. And then we will take our shot at this graph. So please follow me for a second. Follow my hand. From -infinity, the function increases, approaching the x-axis, and at -1, 0, it's turning. Comes down to cross the y-axis at 0, -3. It has to turn somewhere because it crosses 3 at 3, 0, and it's going to infinity. One more time. from negative infinity, comes up to negative 1, 0 on the x-axis, where it turns, comes down and crosses the y-axis at 0, negative 3. It has to turn because it comes back up, crosses the x-axis again at 3, 0, and goes to infinity. Let's graph what we just said. If I don't have the summary here, by looking at all this, I will not know how to graph and what to graph. So, we start by plotting the points we have. Which points we have? Yes, I have negative 1, 0 right here, and I know that this must be a turn. I have 0, negative 3, and this is the y-intercept. And I have 3, 0, which is 1, 2, 3. I'm looking at my chart one more time. Let me do this because I have to have it and explain it. Ready? From negative infinity, it's coming to a turn at negative 1, 0. From negative infinity, it's coming to a turn. Then it will be crossing the y-axis at 0, negative 3. It has to turn again somewhere here because it's coming again, crossing at 3, 0, and going towards infinity. Yes, I know that this is a local max, and I know that it's negative 1, 0. I do not know this local min, but I know for sure that this is the graph of x plus 1 squared x minus 3. Now, I will put in the graphing calculator. Did I turn this on? Yes, I did. Okay, so in y equals, clear if you have anything. I don't have anything right now. So in parentheses, x plus 1 squared. In parentheses, squared. In parentheses again, x minus 3. And close the parenthesis. I know where the action is, right? So everything happens somewhere between negative 3 and 3, roughly. So let's keep it as standard. Zoom 6, and let's see what happens. As expected, it's coming from negative infinity. It has a turn as we expected at negative 1, 0. It crosses the y-axis at 0, negative 3. Has to have a second turn because it comes back and crosses at 3, 0 and goes to infinity. I don't need to find the maximum here, but I need to find this minimum. So I will go to second and calc, find the minimum between 0 and 3. I know it's somewhere between x equals 0 and x equals 3. So, second and calc, I want to find a minimum. Oops, it doesn't do that like that. Okay, so between 0, yes, the left bound 0 is fine. Right bound 3, yes. And I don't want to guess, just give me the minimum. So it gives me the minimum to be at 1.67, and I put in the chart 1.67 and negative 9.5. Say it again. Second and calc, yes. So we go to second and calc, and we choose the minimum, number 3. And I have to give a left bound of 0, enter, a right bound of 3, enter. I see that I have those limits here. I want the calculator to find the minimum between x equals 0 and x equals 3, and it will give me that. I don't want to guess, so no guess. Enter, and it gives me 1.67 and negative 9.5. I'm sorry, press enter. I don't want to guess. I have no idea. Say it again. Maybe the function is put in incorrectly. No, the function is fine. So second in calc, and you want 3, and put in 0, enter, 3, enter, and enter again, and it gives you 1.67.
Okay.
Is it okay?
Yeah, what if we don't have a graph?
You can use mine.
But is that gonna show up like on a test?
Yes.
So,
What part is not clear? This was just the first problem. Don't expect that you will understand
I mean,
everything.
like, if I don't have a graphing calculator and that question shows up on a test, I won't be able to give you a local minute. Because I don't have a graphing calculator.
But you can use mine.
Oh, like during the test?
Yes.
I-
Yes, Marcus?
So in the test, it's gonna ask us for the math, the local math.
Yes.
Okay, is it gonna ask us to graph it as well?
Yes.
Oh.
Yes. Yes.
About the, I guess, the multiplicity,
Yes.
do you have to show that it's taking a long time to go down on the turn?
You mean in the chart?
On the actual graph?
Because
So you said that like on the graph, when you graph the multiplicities, it takes a longer time to turn. So when we're graphing it on the test, where's at -1, should it
Oh,
take
you'll see in a
longer time?
minute. You will see in a minute.
Okay.
We're going to have something like that. Yes. Very good question. No, in this particular case, it's a term because multiplicity 2. But if the multiplicity is 4, it will look a little bit different.
Okay.
It will look like this, not like this. Not a quick turn, but a slow turn. Yes. So this is a function of degree 3. Let's take a look at a function degree 4. So let's choose between 41 and 64. I would like something like 49 or 50, if you'd like. Okay, let's do 50. So this is indeed problem 50 on page 378. And that is -2x to the 4th plus 2x cubed. I get my chart going. Now we know what we have to put in the chart. Domain. Correct. And behavior. What degree is this? 4. It means that it's similar to x squared or similar to negative x squared. Which one is it?
Negative x squared.
Very good. So the end behavior will be very good. The y-intercept, when x is 0, y is?
0.
Very good. Awesome. Degree. Max possible number of turns. It doesn't have to have it, but it cannot exceed 3. Awesome. Good. X-intercepts. And we're done. Can anyone give us the starting point for finding the x-intercepts? Very good. Y equals 0, which means -2x to the 4th plus 2x cubed equals 0. Remember, you cannot get rid of any x value, but I would like to ask you first, how many solutions will you give? Of course, because the degree is 4. I am allowed, yes,
How did you get
degree minus 1. Degree minus 1. Number of turns, degree minus 1. Always think in terms of linear function, degree minus 1, no turns. Quadratic function, degree minus 1, 1 turn, possible. So now we divide definitely by -2. I'm allowed to divide by -2, and I should. So I get x to the 4th minus x cubed equals 0. What do I have to do next in order to find the x-intercepts for this function? The greatest common factor. Awesome. Which is? Yes. What is left in parentheses?
-1.
How many solutions again will you give me? Good. Please give me 4 solutions. Yes?
Zero.
How many times?
3.
3 times indeed. Remember, x cubed means x times x times x. So those are 3, right? So you have 3 zeros of x equals 0, correct? Multiplicity for 0. Very good. Multiplicity for x equals 1. What does that mean? What will the function do when x is 1? Cross, straight cross, no waiting, right? Okay. What will the function do at 0? It's an odd multiplicity. There are no turns if it's odd.
Take a look at the top.
Exactly. Take a long time to cross. Awesome. I'm coming back to my chart. At 1, 0, cross. What do I write again for 0, 0? Yes, long cross. Very good. Follow my hand for a moment. From negative infinity, it's coming to the origin. It crosses, but slowly. Not like this, but has to come to a maximum. Because it's coming back and crosses at 1, 0, going to negative infinity. One more time. From negative infinity, comes up to the origin, crosses at origin, but slowly. It has to come to a turn. After it crossed, it goes up to a maximum, because it has to come back and cross at 1, 0 and go to negative infinity. We really don't need a calculator, right? Unless you want to determine, or we need to determine the max-min. Ready? I only need my chart, nothing else matters anymore. I put all the information in my chart. Ready? Zero, 0. 1, 0. It's coming from negative infinity. Does not cross straight, but it takes its time. Finally crosses, comes to a maximum. It has to come back, and now crossing normally towards negative infinity. And this is the graph of negative 2x to the 4th plus 2x cubed.
So I have a question.
Yes?
When it's crossing slowly at a point, it's not really at the point. It's not, a point is instantaneous. So it's like negative 0.000008 to 0.00008 or something.
The
like
only thing is that what happens there is this. When the multiplicity is 1, it goes to the point like this. When it's multiplicity 3, it gets closer and closer, closer and closer, closer and closer, closer and closer, cross! Closer and closer, closer and closer, closer and closer up.
So
Instead of doing this.
So there's a point at which it's like
Only one intersection.
negative 0.000.
Yes, very
point,
close.
negative
Exactly.
0.000
Exactly.
point.
Yes, but here it's not.
Right.
So now with the graphing calculator, let's put in this function in y equals, clear, and we have negative 2 x to the 4th, and then plus 2x cubed. And I'll zoom 6, I will use the same viewing window, and let's see what we get. Not a good viewing window, so let's adjust it. So I go to -2. Okay, I got it. Okay, -2 to, let's say, 3. Y minimum, scale of 1, that's okay. Y minimum, -2. Y maximum, 4. The scale of 1. Ah, I see it. See the difference between this cross, where there are 3 solutions, x equals 0, and this cross, when there is only 1 solution, x equals 1? So it's coming from -infinity, it takes its time, it crosses only 1 point. But there are 3 solutions there, that's why it looks like this. And it crosses and then continues, comes to a maximum, crosses at 1, 0, and going to -infinity. Everything as we expected. The only thing is that we cannot determine this maximum by hand. So, where am I? Second in calc. I want the maximum, which is 4. I know the maximum is between 0, enter, 1, enter. Just give me the maximum. And the maximum is 0.75 at x equals 0.75 and 0.21. And I put it in my chart. It happens that this is also the absolute maximum. There is no other value higher than 0.21. It's absolute max. Any questions? Any questions? I know we only have 10 minutes left. I'd rather do another problem, and I'll give you 10 points. Everyone gets 10 points for showing up, and I have class work for you for next time. It's all right here in my envelope, but I'd rather do one more problem. Or, better, look at a word problem. Here it is. Because I wanted to see how these functions, or where do they appear in real life situation, okay? During a diagnostic evaluation, a 33-year-old woman experienced a panic attack a few minutes after she had been asked to relax her whole body. The graph shows the rapid increase in heart rate during the panic attack. Here it is. By simply looking at this graph, what do you think the degree is? I don't know what they are asking us. Find which time periods, blah, blah, blah. But I want to just look at this graph and identify what could the degree be. And follow my hand first. One more time. One turn. Second turn. Third turn. What could the degree be?
4.
Right? Does it make sense? With a positive leading coefficient, it's coming from negative infinity going back to negative. Of course, in negative infinity here doesn't make any sense because we're talking about human being, right? So, but I see 1, 2, 3 turns. So immediately I think of degree 4. Correct. Okay. For which time periods the diagnostic evaluation was a woman increasing?
From -1
From 1
to
from 1 to 4, and then from
8 to 10.
you see that increase. Okay. Why did I leave that marker there? Okay. For which time periods during the diagnostic evaluation the heart rate was decreasing? And 10 to 12. Awesome. How many turning points? We already answered that. From increasing to decreasing. How many turning points?
3.
Right. Suppose that the polynomial function, we already answered. For the model in part D, suppose that okay, should the leading coefficient of the polynomial be positive or negative? Positive, right? Okay. And use the graph to estimate the woman's minimum heart rate during the first 12 minutes of the diagnostic. So I want to determine the minimum between the first 12 minutes.
65.
Like 65-ish, somewhere in there.
Right. That is the minimum. What about the maximum?
115, 114.
When? 10 minutes into the study. So this is the way polynomial functions are used. Data is collected on, let's say, thousands of people. Points are plotted, and then they try to fit a function that predicts what's happening here. So that is, okay, we still have 7 minutes. Let's see. Please tell me which kind of function would you like to plot. Would you like a odd degree or even degree? Odd, very good. So let's choose an odd, 41 through 64. Now feel free to choose anything you want, 41 through 64. This section, although it does not appear difficult, and I think you followed through, it needs a lot of work. It's not going to happen very, till you are mastering and able to reproduce all this. Okay, ready? So can anyone give us a odd degree? Any problem you want, 41 through 64.
42.
42, oh yes. He's 42, my goodness. How can we forget? Thank you. What degree is this? How many maximum possible number of turns?
2.
What is the end behavior? Remember, what do we compare it with? We compare it with a linear function because it's odd degree. Is it this or is it this? The first one. Very good. So now you can already fill in the chart. If you don't like my chart, invent your own. But summarize the information somehow because otherwise it will be very difficult. Domain? Very good. You said degree 3, maximum number of 2 turns possible. Good. And the end behavior, you already told me, negative infinity to infinity. Y-intercept, please. 0, comma, negative 4. The only thing I need is? Awesome. And multiplicity. Multiplicity is with it. Okay, so how do I find the x-intercept? Very good. Now I have, how many solutions will I have to present? Awesome. Now the question is, what do I do with 4 terms? Thank you. Awesome. Grouping. Yes, indeed. So please group the first 2. Very good. Look, I'm not looking. Please tell me what to write, what will come out from the other 2 before I look. X plus 1. And now, yes, negative 4. I factor out the common factor next, which is? Perfect. Then I factor. If I don't put parentheses and 0, I will never solve. What do I have inside?
X squared minus 4.
Good. What do I do with x squared minus 4? We have an agreement for more than a month.
It looks happy.
So leave it alone?
It looks happy.
Okay.
X plus x plus 2.
So please give me 3 solutions. Yes. 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 What is the multiplicity for all of them? So what type of cross turn will they be?
Quick.
Quick? What type?
Oh.
You're right. Quick what?
Uh,
Quick cross. Awesome. Very good. That's it. So negative 1, 0. Negative 2, 0. And 2, 0. Follow my hand, and then we'll graph it. That's useful. From negative infinity, a quick cross at negative 2, 0. It has to have a turn because it comes back and quick crosses again at negative 1, 0. It crosses the y-axis at 0, negative 4, and it has to have a turn because it comes back again to the x-axis, crosses at 2, 0, and going to infinity. One more time. From negative infinity, quick cross at negative 2, 0, but it has to turn once because it has to come back and cross again at negative 1, 0. It crosses the y-axis. It has to come back again, and because it has to come back and cross again at 2, 0 and go into infinity. Ready? So I will plot negative 2, 0, negative 1, 0, 0, negative 4, and 2, 0. Can anyone tell us again, where do I start?
Like negative infinity.
And the quick cross. Then
That's what
it has to turn because it has to cross again. Then,
cross.
yes, most probably is going to do this, but we can adjust the graph later, but that's... And then, yes, it has to turn again because it comes back and crosses again at 2, 0 and go into infinity. And this is the graph, and I'm going to say Tim. So we know what graph it is. You picked it. It's his. So y equals, clear if you have anything in there. Oh no. Oh, okay, good. Okay, so we had x cubed plus x squared plus
Minus
x squared minus 4x minus 4, correct? Minus 4x minus 4. And let's use Zoom 6 standard. I don't like it. I'm not going to like it. But let's say, oh, I do like it. I thought it would be too close here. So it's coming from negative infinity, crossing at negative 2, 0. It has to turn because it comes back again and crosses at negative 1, 0. Crosses the y-axis at 0, negative 4. Has another turn because it comes back and crosses again at 2, 0. I can determine the max and the min. The max is between negative x equals negative 2 and x equals negative 1. So what am I doing? Second and calc. And I want maximum, which is 4. Between negative 2 and negative 1. Negative 2, enter. Negative 1, enter. No, I'm not going to guess. I refuse. So negative 1.5. So this point is negative 1.5, comma, 0.88. And now I want to determine the minimum. I see it's between x equals 0 and x equals 2. Second and calc. Minimum between x equals 0 and x equals 2. And no, I don't want to guess, just give me the answer. 0.87, comma, negative 6.1. Or negative 6.06 if you want. We know absolutely everything about this function.